at the back, you can hear me, yeah? Okay, perfect. So, hi everyone. Sorry for the for the wait. We have, as usual, technical difficulties. Today I'm actually going to be talking about, well, quite the big why. So, but pretty much like, the tech stack for WebAI, which is WebAssembly, WebGPU, and WebNN. So, I don't know if, have anyone actually worked with these technologies before? Yeah? Okay, good. Then great, because I'm also actually focusing more on kind of, you can say like introduction to all these three technologies. So hopefully after this, it can encourage you to go out and try these technologies. So, ciao, I'm Susanna, and I'm based in London, and I'm currently a staff software engineer in QuantumBlack Labs. So I'm actually a front-end engineer, so I'm not an AI engineer. And what I do is I actually build a lot of apps for, you can say like MLOps. So I work with a lot of data scientists the people who actually are the brains of all these like AI stuff. And I build applications for them. So like most people, I'm a software developer. And I'm also a Google developer expert in web technology. So yeah, that's my domain. And so fun fact, I used to be in the architecture field, but building architecture field. So I did my master's in building architecture technologies and worked for basically about 7 years in the industry. So yeah, and I worked for like a few, like I would say like quite famous architects. So in case if this is also something you're interested in, feel free to talk to me. I love architecture and yeah, also architecture geek. And you can also follow me on X, yeah, I keep calling it Twitter. But honestly, I haven't been on it since, for the past 2 years. So you can also find me on LinkedIn as well. So first, let's start with a demo. So I'm going to actually switch to, yeah. So of course, I'm sure everyone here has used ChatGPT before. But this is an LLM that's hosted completely locally. So you can see, I literally have no network here. Sorry, where is my mouse? But anyways, trust me, I have no network here because I don't have this certificate, whatever, to connect to a network here. So does anyone have any questions you want to ask this LLM? Anyone? Okay, so I'll ask one then. So I'm gonna try to, excuse me if I can't find my mouse. Where's my mouse? But anyways, you can see all these answers. These are just literally questions that I just asked a few moments ago with no internet. So I asked them about where I should visit in Venice. I asked them some trick questions. So these are all done basically by this LLM that's like hosted locally on this browser, and that's actually like basically utilizing WebGPU and the Llama model, which is completely open source. Like all this done is free, and you can pretty much ask all these questions for free forever offline. So that's like the power of WebAI. Yeah. Where is my mouse? That's oh, okay. Sorry, I can't seem to go to this. Okay, now I'm here. Okay.
Okay.
Oh, I'm back here.
I think
Okay, so okay, you know what? Let me try to find out the some setting stuff. Sorry, technical difficulties again. Appearance.
it's but mirror maybe moment up. No, the display.
Display, yeah.
Yeah. Display. Okay.
Okay.
Extended. Okay.
Yeah.
Or you
Arrange. Okay.
Yeah. Perfect.
Okay, perfect. I think I have got control back of on my mouse. Okay. Oh, sorry, my WhatsApp. Yep. Okay. But anyway, so let's go back to playing this. Okay. So, well, you've seen the demo. Feel free to grab me actually afterwards to play with it if you don't trust me. It's all offline and it can answer all your questions. And so what is WebAI? So WebAI is very different from cloud AI. So the typical ChatGPT you play with utilize a lot of cloud technologies, but it's different in the sense that all the operations are done directly within the browser. So it removes any need for any like constant reliance on these cloud infrastructure. So it allows all these AI models to run locally on the user's devices for all these high performance in-browser computation. So unlike cloud AI, so it requires sending all this like data to all these remote servers to do all these calculations, and the LLM like sits like somewhere on the server. So it basically enables a lot of these like kind of decentralized and client-side execution. So in this words, it allows you to like there's a lot of privacy, reduces a lot of latency, and allow all these like offline AI capabilities. The main thing is like you can also run independently on various devices while it's you can still technically when it's it can still share knowledge once it's back online, so it can download the latest like any latest versions of the LLM, and can also updates, and also you can also share insights across the network. So the thing is, why is WebAI relevant? So the biggest point is, I don't know whether has anyone built any GenAI apps here or like used the OpenAI? Yeah, so the tokens, they actually, once you start racking up, it can be quite expensive. Or basically, you can say like, as your app continue to build, it will pretty much you need to do a lot of like, cost exercise for your app. But in this case, like running all your AI models locally in the browser will kind of pretty much reduce all this need for all this, for example, like expensive cloud infrastructure, and also you can actually avoid all these like expensive API calls. You just need to kind of be more, you can say, as long as you have the latest like open source models, you have to be, of course you need to do more management of your model versions, but you pretty much eliminate all the costs for these expensive API calls. And also, of course, there's much lower latency because everything is run directly on the user's device. So of course you don't need to send it to the server. You don't need, you don't need to like wait for network and everything. So in some way, it's actually a much more like kind of smoother user experience with more like real-time responses. So, and also one of the main point of this is that there's actually a lot of enhanced privacy in this because nothing leaves your computer. So everything is done within your device on the browser. So this is actually a very good use case for a lot of like, institutions like finance institution where they're dealing with a lot of like, sensitive client data. So this is actually also a very good use case for WebAI. So what you see here is, you can say pretty much a core tech stack that enables WebAI. So a lot of like, for example, when you work with a lot of these like data scientists or like, AI developers, they will pretty much build a lot of models using kind of what they call frameworks, for example, like TensorFlow or, and there is also like PyTorch, like these are some of the more popular ones. And then these models can then execute in the browser via either like TensorFlow.js or on runtime web. So these are like runtimes that will make use of these web APIs. So that's where these web APIs, for example, like WebAssembly, WebGPU, or WebML, these are the kind of APIs that these runtime will make use of to access all your underlying CPU. So with Wasm, then you can access your CPU through JavaScript, or you can access your GPU through WebGPU. So I'm going to actually do a deep dive into both technologies in my next bit of my presentation. So now, actually, first of all, let's do a deep dive into that jewel of this tech stack, which is Wasm. So what is Wasm? So Wasm is a binary instruction format designed to execute code efficiently on modern web browsers. So it can do near native performance, but because mainly allow code that's written in languages like C, C++, and Rust to run directly in the browser. So it is platform independent because as long as you have a web browser, you can run any code written in Wasm. So unlike C, C++, or Rust, you need you need to specify the specific hardware, but then with Wasm, web browser, and that's it. So the main goal, of course, is to kind of boost this performance and provide a lot of you can say this secure sandbox execution environment that is very good for like these compute-heavy tasks, like for example, web games, simulations, or camera, all these like multimedia apps. So for example, if you see here, all these like, it pretty much shows how Wasm can compile all these like high-level languages into this like a module that's executable in JavaScript. And it flows, once it can be executed on the JavaScript, then you can execute on the browser, and then you can easily basically use it on any device, even like your mobile phone. So why is Wasm very good for WebAI? So the main thing is Wasm will enable all these AI models to run, of course, at near native performance in the browser. So which is pretty much like crucial to enable all these like heavy tasks like deep learning inference. And also it has cross-language support because, as I said, you can write your AI code pretty much in any like Wasm support language. Like you can write it in Rust, you can write it in C++, you can write it in Python. And you can run it in the browser without relying on JavaScript. And that's key because a lot of the all these like AI developers or application developers, they develop using these Python libraries, and then you can make use of Wasm to kind of compile it so that you can execute in JavaScript. And of course, big part is portability. You just need a browser. That's it. You don't need to make sure like that laptop has of course you also need to assume that it has a CPU underlying it, but you can distribute it as long as they have a browser. So it's very easy to be portable across devices. So why, how are the ways that you can use Wasm to, optimize all these like AI models? So the main bit is it's for model compilation. So you can actually, once, you can actually compile all these AI models or these like kind of AI pipeline, like tensor operations, model layers and all this, using languages like C++ or Rust, and then they can be optimized and be run through the browser, through Wasm. And of course, with Wasm, it enables you to utilize a lot of parallel processing. So because it supports SIMD, what they call single instruction, multiple data instructions, so you can actually perform multiple calculations in parallel. So unlike JavaScript, which is single-threaded. So it's very good for these AI tasks like matrix multiplications and convolutions in neural network. And it's also, another bit is actually it's very good also in interfacing with WebGPU. So Wasm can access your CPU, but it doesn't have access to your GPU. However, it can act as kind of this bridge between all these like high-level AI code, which again, you do it in Rust or C++. And it's, for example, you set all this for model processing or you opt for all these optimization algorithms. And then you can actually offload them to the GPU via WebGPU, as long as it's compiled as a Wasm module. So in this case, for example, let's say you have a real-time image generation app. So Wasm can pretty much handle a lot of these like model logic. Like, for example, you can pre-process all these images, you can run all these like matrix operations, while the WebGPU will pretty much accelerate all these like heavier tasks like neural network inference. So another example is pretty much you can also use Wasm to run these optimized AI models in TensorFlow.js with Wasm backend. So Wasm backend, we pretty much, it improves there's a lot of significant improvement in the performance for all these models compared to, like, let's say if you write, a typical JavaScript backend with Node.js or other backend. So, literally you plug your models on the, that's loaded on the front end with this Wasm backend. And it's very useful for a lot of devices without, that doesn't have access to WebGPU, or in the cases where WebGPU is not fully optimized, then you can plug it with the Wasm backend. And then in the previous slide, when I've shown you the tech stack of WebAI, so I've actually mentioned that ONGS is another runtime engine that allows you to run all these models in the browser. And then what ONGS runtime is actually a very, you can say high performance cross-platform inference engine designed to accelerate all these execution of these machine learning models in the ONGS format. So it can be used across a wide range of hardware, like CPUs, GPUs, and so on. So I'm not going to go into details, but definitely read up on this. But my main point here is that it supports WebAssembly. So obviously, the main point is that, it actually supports WebAssembly to run all these models that's done in a lot of frameworks like PyTorch or TensorFlow. These are pretty much the frameworks that a lot of data scientists build their models on, and then they run it directly. They can actually do it via ONGS.js and allow it to run in the web browser through WebAssembly. And another bit is they also another bit is ONGS.js also, they have a robust fallback to GPU acceleration via WebGPU, which actually I'm going to talk about now in my next section. So WebGPU. So I briefly mentioned it before, but first of all, before we dive into what WebGPU is, why is GPU computing so important for AI models? So the main bit, again, like Wasm, it has GPU has actually a lot of parallel processing power, and it's even more powerful because you can handle like thousands of operations simultaneously. So it's very good for all these AI tasks like matrix calculations and neural network training. And of course, the main bit is a lot of people use GPU mainly for training. So GPUs will speed up a lot of backpropagation and other core tasks in deep learning, and it will reduce a lot of training times. Like, for example, on the CPU, you might need days to train it, but on the CPU, immediately becomes just hours. And this also is very good for real-time inference. So for example, when you have a model that's already trained, you just wanted to do all these predictions, then it's also very good for that. And it has a lot of very fast decision-making in the AI applications. A lot of this is enabled via GPU. And of course, particularly you also wanted to handle large models. So for example, if you use an LLM, pretty much you have to utilize GPU. So the CPU is not enough for all these like very complex models like deep learning architecture and so on. So of course, scalable performance, the main bit I want to say is also it's better than CPU because you can also stack GPUs up. So you can stack them up to do this multi-GPU setup for distributed learning. So again, it's faster than CPU in that sense. So so what is WebGPU? So WebGPU specifically is actually a web API, and it's mainly used, of course, to allow you to do these high performance graphics and compute capabilities. So has anyone here used WebGL before? Okay, amazing. So okay, quite a few. So in that case, I guess you have heard of WebGPU, or have any? Yeah. So and have you even looked into migrating your WebGL apps into WebGPU? Yeah. Okay. Okay, but you can actually start looking into it because pretty much WebGPU is replacing WebGL. So in the future, like for example, if you're thinking of doing these kind of like GPU intensive like online gaming and so on, pretty much people will build it on WebGPU nowadays. And so it's very, again, as I mentioned earlier, very good for parallel computation, and also very good. So it's a very good environment for doing all these like complex algorithms like machine learning models. And here you can see this is pretty much the ecosystem that already uses web GPUs. Like for example, like you can see like, 3JS. Has anyone here used 3JS before? Yeah, pretty much like, underneath the hood, you can like, utilize web GPUs for all the things you build on 3JS and on Unity. So what you can see here, this diagram here is pretty much summarize how the web GPU will interface with your web app and also your local GPU. So every like laptop or every computer, there is the native. They would actually have a native GPU APIs. For example, I have a Mac, so it's called Metal on Mac OS, and it allows a lot of these like native applications to utilize the GPU's capabilities by sending all these like So basically, you need to access the native GPU API, in order to access the driver to access the underlying GPU on your machine. So of course. Of course, a lot of systems, they might actually even have multiple native APIs and drivers, but it's usually just only the focus is there's only on one to communicate with the GPU, and of course, and that's how you enable all these like high performance graphics and computation. But in this case, in your web browsers, what web GPU does in this case is that it's pretty much this interface to communicate with your native GPU API. So it has this adapter. The main communication bit happens in your web GPU adapter. So this pretty much, that's how you access the GPU, or how your underlying system is represented within web GPU is through this adapter. And then whenever you make a web app, so that's what each logical device links to. So it allows all these web applications to access the GPU environment via in a very, you can say like a compartmentalized and secure manner. So each web app will have its own logical device to access the underlying adapter in your web GPU, and that's how you access the underlying GPU in your local machine. So, for example, in this case, like all this architecture, what you see here, it doesn't matter. So all you need to do when you're building your app, all you need to be aware of is the web GPU layer, pretty much your adapter and your logical device. That's all you need to know in order to like, basically access all your GPU features. So this example, just a very, very simple example, but I just want to show you how easy it is actually in reality to use WebGPU. So again, this is a very, very simple app. You just, basically set up a WebGPU component to, you just use it to, run a pipeline and draw something very simple on your canvas. So you need to first request the GPU adapter, which I've shown before, and then you need to set up a pipe, and you need to create the logical device, and then you do, whatever pipeline it is, and that's how you use that logical device to send the things to your GPU queue. So again, to request a device, it's very simple. You just call navigator.gpu request adapter. That's it. That's how you request your adapter, and then you use request device to make that logical device. So that's pretty much all you need to do to get that set up. And then of course in this case now, because I'm drawing on the canvas, that's how I need to bind the canvas to the WebGPU logical device. And then of course then you do your pipeline. I've kind of abstracted it. And then afterwards, you just pretty much then you need, for every operation that you want to basically run in the GPU, you need to create a command. And then you need to send the command to the GPU queue via the command encoder. So you can see all the other code, pretty much your application code, but it's pretty much like these 5 core main commands in order to send things to your GPU to execute things on the GPU. So it's not rocket science. It's actually quite straightforward. So in this case, okay, let me. So here let's see it. This in action. So this is actually a web app. All this is done on a web app. And this is actually a Hugging Face demo of Meta's segment anything model that will kind of produce a lot of these high quality object masks directly on the client. So what I want to show here is this, for example, this WebGPU benchmark for text embedding will there's actually a much more speed up. So for example, if this is implemented on the CPU, not via WebGPU, then it will take much longer time. But in this case, at least it's 30 times faster than running on the CPU. And on some machines where you even stack the GPU up, then it's actually faster than more than 120 times. So here, it's just pretty much this summary of the differences between Wasm and WebGPU. So main important part is that, look, they serve quite different purposes in the WebAI development. So think Wasm, CPU-bound task, WebGPU, GPU-bound task. So Wasm, in other words, you can use it for more, you can say general purpose computation. So for example, if you want to do a lot of processing of the data before sending it to the model and so on, then you use Wasm. And of course, if the things are written in C or C++, do it in Wasm. But then you can use Wasm to offload all the tasks that you want to use on the web GPU for example, for all your training tasks, even for your inference tasks. That's when actually you can utilize your web GPU. So now, actually, this will segue into the next API, which is WebNN. It's a very cutting-edge API. So have anyone of you heard of WebNN? No? Okay, great. So what is WebNN? So WebNN is you can say it's a web standard that will enable machine learning inference directly in the browser. And the key thing is, because you know how Wasm can only access CPU and WebGPU, of course, WebGPU with the GPU, WebNN have access to both. So it can do a lot of these hardware acceleration. And the beauty of it is that you don't need to specify it. It will actually do it in the background for you. So, and the main purpose of WebNN is pretty much for running neural networks and AI models natively in web applications. So, in other words, with WebGPU, you can use it for games, or you can, with Wasm, you can do it for fast, data processing. WebNN purely AI-related work and running web neural network inference. So pretty much what you see here, this is kind of, you can say the architecture of surrounding WebNN. So web browsers can implement the WebNN API using native machine learning API available in the operating system. So to be honest, for us, as developers, you don't really access all these native ML API, but once you access WebNN, underlyingly, they have access to all these API underneath the hood it is actually through this that's where they can like know how to like optimize between the different hardware between CPU and GPU. So you can say WebNN is pretty much this abstraction layer on top of all these like underlying technologies. So you can see here, this is just one example, like, how WebML would work with Wasm. So the WebML, this graph actually works very well with Wasm kernels in that, like, for example, after preparing data preparation operations on Wasm, then you can then quickly offload all your inferencing tasks on a pre-trained model to WebNN. So, WebNN will do the best job in doing all these neural network operations, and then will feed the results back to Wasm, the Wasm kernels for post-processing. So, so one very important thing is like as I mentioned, it's a very cutting edge API. So it's actually only in the candidate recommendation phase with W3 as of now. So it is an API that is currently in active development, and there are many frequent updates. So of course, I would encourage you to, if you were to use it, just use it kind of, I wouldn't say to use it in production, just use it, as experimentation, as thinking for now, because that API would drastically change. And also, it's currently now, well, I think as of last month, October, they were actually, they have a deadline for comments, with W3C for the next batch to update the API. So I think we're a bit too late for it, but they will have one upcoming up. So, it's also a very good time to shape the API. So now that we've gone through all those three technologies, how does everything come together? So in this section, I'm just going to walk through some of the different like type of tasks within that AI lifecycle that you can utilize all these different technologies. So, and by the way, you see all these diagrams? They're not done by myself. They're done by my friend, Dolly. So, they're not completely accurate, but just, they're more like artistic purposes. So don't take them, seriously. Yeah, they just take them with a grain of salt. So the first bit is like, of course, you need to load a model, you need to do all this in the initialization, then that's actually when the best way to do it with Wasm. So for example, when an application starts, so the AI model is usually loaded, you load it in a Wasm module, and then you can load module files, you can do all these like pre-processing steps, like for example, you want to convert an image data to tensors and all this, prepare kind of the model for future inferencing. You do it via Wasm. And then the next bit is when you start to think about like, okay, so now I need to do my inferencing, then that's when you start looking into using the GPU. So, or basically you can offload it to WebNN as well. So you use WebGPU for these like heavy parallelized tensor operations like matrix multiplications, convolutions. Honestly, I don't know what it means, but I know that when you want to do inferencing, offload it to WebGPU. And then if you want to also kind of like load an existing model, then you can, because WebNN, there's actually a lot of models that you can download online and simply just plug it, integrate it with your WebNN, with the WebNN API. So you can also do it via that way as well. And then it's pretty much abstract all these like neural network operations. And if you, because with GPU, WebGPU, you still need to know a little bit about, you need to think about how you create the command and tie it with your logical device. With WebNN, it literally abstract all that. So you can also use WebNN in this instance. And then the next bit is, for example, like there are bits where you want to kind of create a custom AI layer. So it's a very specific use case, but like, for example, I don't know, like you want to, let's say you download a model and you want to do a very specific extra neural network layer on top of that, then that's when you need to look into using either writing it yourself in WebGPU or you can write it in Wasm. So like, for example, like some AI models may need these so for example, you can use Wasm to handle the logic and orchestration to handle everything into that custom layer. And then you use WebGPU's compute shaders to define and accelerate all these custom operations. Yeah. So, and the last bit is, of course, if you want, most likely, as everyone as web developers, we will build these kind of real-time AI and interactive applications. That's actually the part where you will pretty much utilize all three technologies. So for example, if you want to do like object detection, face recognition, style transfer, then you combine all these three technologies together to build your app. So of course you load everything by WebAssembly, you can use WebGPU for inferencing, or you can just plug everything into your WebNN. You can download an existing model and use WebNN to do your operations. Yeah, and of course that's you will also use WebNN because you want to kind of like want to abstract that hardware layer. You don't want to worry about what hardware to use. Yeah. So this is just one example workflow of a web app that can utilize all three technologies. So for example, first of all, you do initial model initialization. For example, you load the AI model, and when you will load it via Wasm, and Wasm will do all the pre-processing like resizing, normalizing the input data, and like with your images, you do it via your Wasm module. And then the next bit is when you do model execution. So once the model is loaded, then you start inferencing. And then you can use WebNN to call these high-level AI operations like convolution, activation, and pooling. And then you will then select which best hardware to use, whether it's CPU or GPU. And in some cases, though, one thing is WebNN is not supported by a lot of browsers. So, for example, in Chrome, it's only supported by Chrome Canary and even very, very cutting-edge versions. So, in most cases, WebNN is actually not supported. Then you can directly use WebGPU to write these custom shaders for matrix operations. And of course, if you have a very custom operation or layers that's not directly supported by WebNN, then you do it in WebGPU. And then finally, once you do all your inferencing and get all your results, then you actually put it back into your Wasm module that would do all the post-processing and analyze all the results. For example, like if you want to analyze all the output, extract all the labels from a classification model or the kind of bounding boxes from an object detection model, then that's actually where you put it all back into a Wasm module to do all this post-processing before you pass it back to the JavaScript environment for your web app. So this is just a very high-level overview, but in the next section, so how does everything come together, and what are the kind of decision framework that you should use as a developer when you're deciding between all these three technologies? So this is what this section is. And by the way, this is gibberish. This is generated by Dolly, so artistic purpose. So the first bit is you really need to understand all these like core technology capabilities. So I've gone through actually all these three different technologies in detail, but again, Wasm, you really need to think it's the main core strength of Wasm is just high performance execution of code. So it's not very optimized for doing like, parallel. It is good for parallel processing, but not as good as GPU. But if you want something to execute the code really fast, that's when you use Wasm. But with WebGPU, that's when you want to really think about like all these like graphics. It's a next-gen graphics and computation API. So in this case, when you want to do a lot of things that need a lot of parallelized computation, then that's when you use WebGPU, like matrix multiplications and so on. And the WebNN is the core strength for WebNN, and it's very relevant maybe for us, at least for myself as a JavaScript developer, is that it's a very high-level API that is used. The core goal is to simplify all this machine learning inference on the web. And the beauty of it is you don't need to, there's this hardware abstraction layer. You don't need to think about, okay, when am I going to pass this to the GPU? And should this task, if it doesn't go to the GPU, then how should I, use it? How should I, deal with these edge cases? You don't need to worry about that. WebNN will pretty much decide it underneath the hood. And also you need to think about so some of the primary use cases where you use Wasm. So for example, a lot of the cases, if you work with a AI engineer, they will pretty much build their own, let's say if they build their own custom pipeline and they build it in C++ or Rust for these fast processing, then that's actually obviously you compile it as a Wasm module. So you can utilize and port existing models via that way. And then of course, if you, and also these kind of what we can say computationally intensive tasks that need CPU execution, Wasm. And then with WebGPU, so if you want to train, the keyword is train large AI models that need all this massive parallel computation, and cases where you even want to stack GPU computations at GPUs together to kind of accelerate all these training tasks, that's actually when you can put everything into your WebGPU adapter and the process. So for example, if you want to do these real-time performance needs, for example, if you have interactive AI, you want them to ask questions and immediately get back to you, you want to do a lot of video processing with a lot of bounding boxes, then these are the cases where you should really consider using WebGPU. And of course, with WebNN, the case where is if you you don't want to train your own model, so you just want to utilize what's existing on the web, the pre-trained AI models, and then if you have less concern for these like fine-grained control over the execution, then that's when you use WebNN. And to be honest, as developers, most of the case, if you don't want to train your own models, you pretty much can just play with the WebNN directly. You don't need to worry about the WebGPU. And the next bit is, of course, consider your, requirements. So if you're, so in this case, if you need to train large models like deep neural networks in the browser, you will benefit from WebGPU because you can leverage GPU power for these large-scale parallel computation. But if you just simply inference, like you want to run these pre-trained models, then of course you use WebNN. It abstract all the kind of like hardware acceleration complexity underneath the hood. And also you need to consider your model size. So in this case, like if your model is very lightweight, so let's say it's not an LLM, it's just a simple model that, let's say, do like, a very specific task like speech detection and so on, then you can use, then of course you don't need WebGPU. You can just use it via Wasm, or you can use WebNN. But if you have a very large model, like, like vision or like deep learning, in my previous case, like let's say it's an LLM, then you pretty much need a WebGPU. Otherwise, you pretty much doesn't have that, computing power to run that model. And also you need to think about your target hardware environment. So this is, again, at least as web developers, you really need, when we develop something, we need to think about the user's hardware and what we can access to. And then if, in this case, of course, this is just a simple, if there is a high-end GPUs available, then of course you use WebGPU. And then, but for example, in the case where your users, they might have these high-end GPUs, but they could access your app via, let's say, a phone, which might have a CPU underneath the hood, or like just a simple laptop, then that's actually when you can use WebNN, because WebNN will kind of adapt to the hardware, and they will have, they will, underneath the hood, they will do all this like balance of performance, abstraction, and so on. And of course, in this case, if you know the user will only have CPU, and you don't know whether they will have access to GPU, then of course you just pretty much write all your models, and you can even do all your inferencing on Wasm. And again, you also need to think about cross-platform though, because if you want the app to work everywhere, it's highly portable, then set up most of your operations on Wasm, because you can at least know that most devices will have a CPU, but not all of them will have GPU. But if you want to, let's say if you're building an application for a bank that everyone on that device has access to these high performance Mac machines, then you can pretty much know that you can use WebGPU, or you can use WebNN that can also utilize the WebGPU. So another bit is also, as a developer, you really need to think about your development effort and learning curve. So of course, Wasm is on the high spectrum end, high effort end, because Wasm, it's very general. So it's just, you can say like compiler, you can write everything in your native code. But in that case, it allows you a lot of low-level control and performance, pretty much anything that you get from native code. But if you were to use it to write, use it to compile, or use it to develop your AI models, you need a lot of manual work to optimize the operation. You pretty much need to write everything yourself if you're just purely on Wasm. And WebGPU, again, it's actually easy to use, but underneath the hood, you still need to know, how to do these kind of GPU programming underneath the hood, or you need to have a good idea of it. So, for example, in the case where you want to write these custom AI layers, like these custom shaders for specific ML tasks, then you still need to learn and know about it. But with WebNN, the learning curve is much easier. So, you pretty much don't, all this hardware underneath the hood is being abstracted, and it's actually, and it simplifies a lot of this deployment as well. So it makes it very, for teams, for example, your team are mostly JS developers, and then they can just learn about the simple WebNN API. They don't need to learn all these CPU and GPU computing underneath the hood. And also, you need to think about all the existing tools and so on. But okay, sorry, that was, I'm not going to go through that in detail, because I've gone through a lot of it. But for example, with WebGPU and all that, there's a community there, but a lot of it is very, very, you can say specific, web graphics community. So you still need to kind of like dig through. There might not be as much resources, but with WebMN, you pretty much think about using it for a very specific set of pre-trained models. Yeah, so it's not as, there's also a very limited amount of models that you can use on WebMN. Again, I guess we're out of time, so I won't go too much in details about this. But again, you need to think about what libraries there are. So for example, if you want to use WebMN, you're pretty much restricted to only using these popular frameworks. But with Wasm and WebGPU, you can pretty much use anything. So you can work with an AI engineer. You can use PyTorch. You can use, for example, in our company, we have this framework called Kedro. You can build all your pipelines on whatever library you want out there. As coming to WebMN, and you're pretty much restricted to only a few that is supported by the API. So again, you need to think about future-proofing. The main thing is with Wasm, everything is custom, so you need to constantly update your model so to make sure that it's pretty much up to date with the latest performance. But with WebMN, again, it's very high level. So if there are new updates, you just pretty much you can just update the model version, and that's pretty much it. So you don't need to worry about how with Wasm and WebGPU, because they were so custom, you constantly need to update those code. So these are just kind of the summary of all these kind of development concerns or the framework that you could use between this. So again, I'm not going to go through in details, but if you're interested, you can take a picture of this, to help guide your future development needs. So my last bit is, so Intel actually has released an AI PC. So it's a PC that will empower WebAI specifically to do all these on-device, with very high on-device power. So in this case, in other words, my point is WebAI will continue to evolve, and it's just only going to be more important and more relevant for us as web developers. And pretty much this is what you see as kind of the current full picture of the web AI ecosystem. And there's actually a lot of relevant use case, runtimes, and web APIs. So if you start developing your web AI apps, pretty much these are kind of the things that you pretty much need to understand or will need to understand, when you start, thinking about your own architecture for your web AI / GenAI apps. So honestly, we're just at the very beginning of this journey of transitioning from a normal web app to web AI. And of course, as with hardware advances and so on, so the potential for web AI is pretty much limitless. And honestly, I think we are just at the very beginning of this. And there's going to be another revolution from this Web 3.0 to this Web 4.0, which is pretty much AI-charged apps for very specific use cases. So highly encourage you guys to be one of those pioneers to shape this new Web 4.0. And for me personally, I'm also still kind of on this early journey of learning all these technologies. So highly encourage you to, for us to work on this together. So that's it. That concludes my talk. And thank you so much. If you want to discuss or have anything you want to talk about WebAI, find me on LinkedIn. I'll also be around here as well. So thank you, everyone. And sorry for the overtime.